All right, my dears. Let's go ahead and draw out this first one. We're going to draw 6 by 14. Here we go. So you're going to make your paper look like my paper. 6 on the side. And 14 across the top. Kids are really good nowadays with their number sense in this way, knowing that a 14 is the same thing as a 10 and a 4. Yes, Anna? You can't do it digitally. You have to do it on paper. Okay, thanks, hon. All right, let's go chunk by chunk. And Jessica, what are we going to do at the very end? Add it all up. That's right. So let's go ahead and do this first chunk. 6 times 10 equals, buddy, 60. Go ahead and write it in. What's great about doing an area model is it breaks it up into very manageable chunks. All right, let's do that next section. 6 times 4. And what is 6 times 4, class? 24. And of course, we're going to add it all together. And if you can't add it in your head, is it okay to do a little problem off to the side? You better believe it. For a final answer of 84. So what's 6 times 14? 84. And we figured it out by doing it chunk by chunk or section by section. Give me a thumbs up, sideways down. How you feeling so far? Good. Let's do another one. And we're going to do 8 times 18. Is this pace okay? When anybody watches this video, of course, they can hit pause, right? It would not be good to give students the ability to pause their teacher. Bad superpower. Okay, we're going to do 8 down the side. And across the top, we're going to do a 10 and an 8. You know. Perfect. So what's 8 times 18? Dude, I don't know either. Let's do it chunk by chunk. So our first chunk is 8 times 10. And I expect everybody to answer this. What's 8 times 10, everybody? 80. And what about this? 8 times 8. Do you remember? Will you still need me? Will you still feed me when I'm 64? 8 times 8. Do you remember Mrs. Judson would sing that Beatles song in 4th grade and everybody thought I was crazy? But I did. Jessica, what are we going to do? Add them up. So what is 8 times 18? 144. And it was easy to find because we broke it up into very manageable chunks. Okay, let's go ahead and do another one. 7 times 23. Now, there are 2 different ways to do this, and I'm going to show you both ways, and it's up to you how you want to show it. Do you have to show it both ways? No. Some of you might want to, though, until you decide kind of which way you like better. So I'm going to start by putting 7 on the side. And 23 across the top. I'm going to do a 10, a 10, and a 3. You can totally do it with 20 and a 3. And maybe I'll do, and I'll show both ways in case somebody wants to do that right now. And the answer is totally going to be the same, and there's pros and cons to both. One of them has easier numbers to work with, but there's more sections. One of them has less sections, but the numbers are higher than 10. Okay, so for the first one, 7 times 10 is what, everybody? 70. And then, of course, another 7 times 10 is 70. And then 7 times 3 is 21. Now, if you did it the way where you don't split the tens up, it's really just an extended fact. 7 times 20. And here's how I would do it. I would think 7 times 2 is 14. A 0 in the problem, a 0 in the answer. Look at those green sections. Isn't 70 plus 70 140? Yeah, so it's up to you. If you like to split it into a 10 and a 3, or a 20 and a 3. And there's pros and cons to both. Sometimes it's helpful if you're very neat and organized. It makes it, I don't think, matter very much which one you choose. Sometimes kids that are not very neat and organized like having less sections. And then, of course, this last one is that 7 by 3, which is 21. And, of course, I can see that the answers are going to be exactly the same. Hey, you know what's so interesting about the second one? Is there's less adding to do, isn't there? Right? Only 2 sections to add. All right, so I'm going to do 140 plus 21, which of course is the same as 70 plus 70 plus 21. So what is 7 times 23? 161. Dude, I didn't know what 7 times 23 was. Could I figure it out? Absolutely. Could we figure it out with an area model? We just did. All right, on to the second page, peeps. 9 times 26. Are we ready? Is that what everybody's second page says? 9 times 26. All right, let's go ahead and do 9. Along the side. And 26 across the top. I am not going to do it in both ways, both times, I don't think. You're doing a lot of like break apart and putting it back together, yeah. Who would rather do it as a 10, and a 6? Who would rather do it as a 20 and a 6? Oh, maybe I will show both. Okay, ready? A 10, and a 6. Get a little smaller here. And then I'm going to do you have to show both ways, people? No. But I like that I'm seeing so many eyes up here because I think it is helpful to see it both ways and to see how mathematically it's still the same. It's just maybe based on preference. Okay, let's do the first one. Everybody should say this. 9 times 10 is what? 90. Good. And 9 times 10 is 90. And the great part about that one is that the number never is bigger than 10, right? If I did 9 times 20, 9 times 20, all right, 9 times 20, I would think 9 times 2 is 18, a 0 in the problem, a 0 in the answer. So you can see that those red sections are exactly the same, right? 90 and 90 is 180. Right, and then that last section is 9 times 6, and 9 times 6 is a basic fact, and it's 54. Do you have to show it both ways? Absolutely not, but I do want everybody's eyeballs to look at both ways, just because I think it's good for your eyes to see it both ways. The pro of the second one is that it's less to add, for sure. 180 plus 54, which is the same as 90 plus 90 plus 54. All right, so what's 9 times 26? We just figured it out. 234. Oh, this next one's great. It's a little bit different. Did you notice that the first number is a 2-digit number? Right? All right, 12 times 15. So along the side, we're going to do a 10 and a 2. And across the top, we're going to do a 10 and a 5. Kids that are watching the video can pause, right, if they need to go slower. Kids that are here in the classroom are going to have to keep up or raise their hand and let me know if I need to slow it down a bit. Okay? Girls at home, are we doing okay? Doing great. This is a very visual way to show multiplication. Let's do that first section. 10 by 10 is what, everybody? 100. 10 times 5 is what? What's 10 times 5? 50. Thank you, Annalise. At the bottom, 2 times 10 is 20. And if kids forget anything, what do they forget? That last little corner, right? Especially if their boxes are not super neat. 2 times 5, and 2 times 5 is 10. And of course, now we're going to add them all together. I typically start with the biggest number. And some people might be able to add that in their head, but if you can't, you could add it like this. What is 12 times 15? 180. And the reason it was so easy is because we broke it up into very manageable chunks. Right? Most kids don't know their facts of 12 very well, and they certainly don't know 12 times 15. But if we break it up into manageable chunks, the hardest problem we had to do was 10 times 10. All right, 14 times 17. Here we go. 14 on the side. And 17 across the top. All right, 10 times 10 is 100. 10 times 7 is 70. Doing okay, everybody? 4 times 10 is 40. And if kids forget anything, what do they forget? That last little corner. 4 times 7. And 4 times 7 is a basic fact, but of course if you needed to look at the monsters or a multiplication grid, 4 times 7 is 28. Jessica, what do we need to do? Add them up. Could you add them up, like do 2, and then do another 2, and then add the, yeah, sometimes kids don't like to add 4 things at the same time. What is 14 times 17? 238. And the reason we were able to do it is because we made the numbers much more manageable than 14 and 17. The hardest problem we had to do was 10 times 10. Or at least the biggest one we had to do was 10 times 10. All right, third page, 6 times 32. Who's going to leave the 30 as a 30? Who's going to make it a 10, a 10, and a 10? I'm going to show it one way, but of course you could break up 32 into a 10, a 10, a 10, and a 2 if you want. I'm going to show it like this. In some ways it's easier, yep. All right, the first section is 6 times 30, which is really just a basic fact. And I might do this with my pencil and actually touch the numbers or underline them. 6 times 3 is 18. A 0 in the problem, a 0 in the answer, 180. And that last little section is 6 times 2. And 6 times 2 is 12. What are we going to do now? Jessica? Add them up. 180 plus 12. Thank you. So what's 6 times 32? Dude, I didn't know that before. I could have figured it out, but we just figured it out with an area model. 192. Very nice. Okay, we are over halfway there. I bet we'll only be doing this for about another 5 or so minutes. 4 times 26. I'm going to put a 4 on the side. And 26. I could break it up into a 10 and a 6. I'm going to show it as a 20 and a 6. And the great thing about an area model is that we break it up into very manageable chunks and then put it all back together again. And it really shows in a very visual way what 4 times 26 means. 4 times 20. Could you count by 20s? 20, 40, 60, 80. You could, right? Or you might think 4 times 2 is 8. A 0 in the problem, a 0 in the answer. And the last section is 4 times 6, which is 24. So now that we've multiplied each individual section, now we add all the sections together. To get a final answer of 104. That makes sense. Think about quarters. If you had 4 quarters, 4 times 25, wouldn't that be 100? So it makes sense that 4 times 26 is right around there. Okay. Whoa, 15 times 21. I demand you to tell me. What's 15 times 21? Dude, I don't know either. Let's figure it out. All right, here we go. 15 times 21. So I'm going to put a 10. And instead of a 10, a 10, and a 1, I'm going to do a 20 and a 1. And let's go ahead and do section by section. Remember, if you're watching this video, you can pause it. If you're hearing class, you can let me know if I'm going too fast or maybe take a nice deep breath. You guys are all doing beautifully. Originally, I thought we would do more practice and then take a grade, but I think we need to do that next week. You know, Mrs. Judson never likes to be rushed, so I think next week is when we'll do that. Okay, we ready? 10 times 20. Just that first section. And you might think something like this. 1 times 2 is 2. 2 in the problem, 2 in the answer. And these are going to be some really tiny sections here. 10 times 1 is 10. I think I'll write it sideways. 10 times 1 is 10. 5 times 20. You could count by 20s. 20, 40, 60, 80, 100. Or maybe like this. It's good to underline stuff, I think, with extended facts. 5 times 2 is 10. 1 in the problem, 1 in the answer. Does it make sense to you? 10 times 20 versus 5 times 20? 5 times 20 is half as big, right? If kids forget anything, I feel like especially in this one, what would they forget? That last little corner, because all it is 5 times 1, which is like super tiny. And 5 times 1 is 5. And let's go ahead and add them up. Yes. Hold on 1 second. Let me add this up. Gosh, my plus sign is way up high there. 315. Let's see. Yes. Yes. All right, very last page. What is it, just 3 more? 17 times 17. I demand to know what 17 times 17. Dude, I don't know either. All right, let's figure it out. We're going to put a 10 and a 7 on the side, and a 10 and a 7 across the top. I don't know if you've noticed, but if there's 2 numbers on the top and 2 numbers on the side, what's 2 times 2, people? 4. So there's going to be like 4 puzzle pieces, right? 4 chunks, 4 sections. All right, here we go. I want everybody to say this. We're almost done. 10 times 10 is 100. Good. 10 times 7 is 70. Another 10 times 7, or 7 times 10, is 70. And if kids forget anything, it's often that bottom last corner. And this one is 7 by 7, which is 49. So we've broken it up into very manageable chunks. The highest thing we had to do was 10 times 10. And now we're going to add them together. $14, $15, $16, $17, $18. So what is 17 times 17? 289. 2 more, and we are done for the day. All right, 13 times 27. I'm going to put a 13 on the side, which is a 10 and a 3. Right? Because 10 and 3 are way easier to work with than 13. Not very many people know their facts of 13 very well, right? 27, way easier to work with a 20 and a 7. But you're right, you also could do a 10, and a 7. You could. All right, I've got 2 numbers across the top and 2 numbers on the side, which means there's going to be 4 sections altogether. 10 times 20. Some people just know 10 times 20, but you also could think this. 1 times 2 is 2. 2 zeros in the problem. 2 zeros in the answer. 10 times 7 is 70. 3 times 20. Let's see, for 3 times 20, I would do this. 3 times 2 is 6. A 0 in the problem. A 0 in the answer. Oh my gosh, are you guys already looking at that last one? The biggest one we've done already. All right, let's not forget this last section, though. 3 times 7 is 21. What are we going to do now, Jess? Add them up. And remember that you could add like 2 at a time and then add those together if you don't like adding 4 numbers at the same time. What is 13 times 27? I didn't know it before, but I know it now. 351. All right, the very last one, whoa. A number in the 20s times a number in the 30s. What is 25 times 36? Dude, I don't know. Well, you already figured it out. All right, let's go ahead. I'm going to figure it out by doing it in more manageable chunks. So I'm going to do a 20 on the side with a 5. Now I could also do a 10 and a 5, but you can probably already imagine how many sections that would have. But some kids find a lot of success with that. Across the top, I do 30 and a 6. And what's great about using the 20 and the 30 is that there's way less sections. There's only going to be 4 sections. And I just need to be really careful when I multiply. 20 times 30. To do 20 times 30, I would do this. 2 times 3, don't say 5. Kids say 5 all the time. 2 times 3 is 6. 2 in the problem, 2 in the answer. Then I'm going to do 20 times 6. And I would do 2 times 6 is 12. 1 in the problem, 1 in the answer. At the bottom, I'm going to do 5 times 30. And 5 times 30, let's see. I'm going to do 5 times 3 is 15. A 0 in the problem, a 0 in the answer. And your pictures are looking beautiful. Some years I have kids that can't manage this at all, but everybody's pictures are looking very straight and easy to see. And the last one is 5 times 6, and 5 times 6 is 30. And of course, at the end, we're going to add them all up. And you can add 2 numbers at a time if you want. Oh, I guess I didn't put this one in order. That 150 was actually bigger than 120. Does it matter the order when you're adding? No, it certainly does matter when you're subtracting, though. Okay, let's go ahead and add it up. 10, 6, 7, 8, 9. So what is 25 times 36? 900, that's right. Excellent job. We will practice more area models at another time.